Find the equation of the normal to the curve y equals a half log 3x plus 2 at the point P where x is equal to negative a third. So if x is equal to negative a third, y would be a half ln negative 1 plus 2, which is a half ln 1, and ln 1 is 0, which is 0. So we're talking about P being the point, negative 1/3, 0. Now we want the normal. So if we've got a curve, and this is the tangent, the normal is at 90 degrees to that. So we can find the gradient of the tangent in the first instance by finding the gradient function. So we want to differentiate. So dy dx is going to be, so what we have here, we'll have a half, and then ln always differentiates to 1 over the function that's inside, and then we have to use the chain rule. So we have to multiply by the differential of the inside function here, gives us 3. So what we have is 3 over 2, 3x plus 2. And so the gradient of the tangent at P we can get by evaluating that with x equals negative a third. So that's going to be 3 over twice 1, which is 3 over 2. So the gradient of the normal, which is what we want, is going to be negative 2/3. Remember, if two lines are perpendicular, their gradients multiply together to give negative 1, and 3 over 2 times negative 2/3 is negative 1. So we know that our normal has this gradient and goes through this point. So we can use y minus y1 is equal to mx minus x1. So y take away 0 is going to be negative 2/3, x take away negative a third, which gives us plus 1/3. So we have 3y equals negative 2x. So negative 2x take away 2/3. So this 3 came up and multiplied over here. Let's multiply by 3 to get rid of this third on the bottom. We'll have 9y is negative 6x take away 2, which gives us 9y plus 6x. Add 2 is equal to 0, or something equivalent to that would do. So we're now told that the normal intersects, the normal to the curve at point P, the normal we've found, intersects the y-axis at the point Q. So y-axis means that x is equal to 0. So that gives us 9y plus 2 is equal to 0. So y would be negative 2/9. And the curve intersects the y-axis at the point R. So the original curve was y equals a half ln 3x plus 2. So y is equal to a half ln 3x plus 2. So if x is equal to 0, that would give us that y is equal to a half ln 2. And we want to find the area of the triangle PQR. So we draw a quick sketch that might help with that. So P is the point negative 1/3, 0. So that's just here. So there's P. And this point here is Q. And so that's there. And then R is a half ln 2. I'm not quite sure where that is, so let's just quickly do that. So 0.5 times ln 2. That's at 0.346. So it's just here. And so we could take this as the base and this as the height of this triangle. So the height here is 1/3 because we know the coordinate here is at negative 1/3. And this was at negative 2/9. And this is at 1/2 ln 2. So the area is going to be 1/2 times the base, which is the last answer I've got on my calculator here. Add 2/9, so 0.568, and so on, times the height, which is 1/3. So we need to multiply that by 0.5 and then by 1/3. And that gives me 0.095. Check that, 0.095 square units, and I've given that to 3dp. Just looking at the mark scheme, they allowed that, although the initial mark scheme did say 0.0948, so they wanted 3 significant figures.